Okay.
All right, let me break out full screen here. All right, we are live. So welcome everybody to the Arduino Sensors, our third Arduino workshop. Tonight, our presenter is Ari. Ari is an alumni of Team 1111 and currently mentoring Team Dave. And yeah, so if during the presentation you have any questions for Ari, go ahead and type them into the chat or raise your hands. I'll try to keep an eye out on that forum. And yeah, the usual stuff applies. If you have any questions in the future, go to Discord general channels and the workshop discussion channel, and you can pose them there or talk to your mentors or fellow students. So I think that's about it. So go ahead, Ari.
Okay. So hello. Today we will talk about Arduino sensors. Okay. So what is a sensor? A sensor is a device that measures a physical property in the world. And like in the sake of an Arduino, it often records that data and prints it, or it does some sort of output depending on what the input is. So a sensor is kind of like an input for the Arduino. All right, so today we're going to cover how to program buttons, potentiometers, and ultrasonic sensors for an Arduino. So a button is like I guess a button that when pressed, it connects 2 points in a circuit. And for an Arduino, it returns 1 or 0. A potentiometer is kind of like a voltage divider, where that's like a dial, where when you spin it, it returns a lower and lower voltage. You can only spin it about 360 degrees. But for an Arduino, it returns a value between 0 and 1023. And then we have ultrasonic sensors, which I think you're getting in your kits. They measure distance using ultrasonic waves. And to do that, so it sends out one wave, and then it waits for that wave to return back to it. And depending on the time it took for the wave to come back, they can do math to figure out like what a unit that you're used to, like centimeters or inches. Okay, so before we go into programming, we're gonna have to learn digital versus analog ports. So for Arduinos, the digital ports are up here and the analog ports are down here. So the digital ports can be seen right here in this graph. They read 1 or 0, typically 5 volts or 0 volts. And the analog pins can range more than just 0 or 1. And for an Arduino, it's usually between 0 and 1023 or 0 and 4095. So before we go into like programming, we're gonna have to learn how to, I think you've gone over how to print, but it's good to go over again. But for printing, you first need to start by initializing the serial monitor, and the baud rate is 9600. And it is the data transmission rate in bits per second. You need to make sure that you set the baud rate here, and on the serial monitor, you should have the same baud rate, just so you can see all the outputs correctly. And to print, you just put in your variable or string message, and this is in loop, so it should print that message continuously until you stop. And to open the serial monitor, you just push this button at the top. And in the serial monitor, you'll see hello world printing continuously as we programmed before. And over here, this is where you set the baud rate. You need to make sure this is the same as it was when you programmed it. So how can an Arduino read sensor data? So first, we need to define the pins. So analog pins, I think it's like, they start with A. I think it's A0 through 5. And digital pins, wait, maybe it starts at 1, but digital pins, I think maybe 1 through 13. But yeah, analog pins start with A. That's how they differentiate them in the Arduino world. And then we have to set up our serial monitor again. And we have to define the digital pin as an input. I think we might also have to define analog pin as an input too. I think I might have forgotten that part in the presentation. I'm not sure. But yeah, so we have, I think you can define, yeah. But yeah, you need to define the digital pin as an input and possibly the analog pin just to let the Arduino know that it should only be used as an input and not an output. And then from there, you can assign the variable. Like we initialized a new variable and we're assigning it to the value, like this function reads the pin. So this function reads pin A3 and puts it into this variable analog val. And that's the same with digital val, except it reads the digital pin. And then we print analog val and digital val to the serial monitor. And now we're going to go over reading button data, and then we're going to go to Tinkercad circuits. Okay, so first we define the pin and the value. The value is initialized to 0. So if nothing like happens at all, it would just print 0, just so we don't get an error. And then we initialize the serial monitor and we initialize like the pin as an input. And then in loop, every time loop runs, we are assigning the digital value of this pin to the variable val, and then we're printing val. And now we'll go to Tinkercad circuits. Okay. Do you have any questions so far? Text. Okay, yeah, we want text. Start simulation. Serial monitor. And so I think this is very similar code to what was in the presentation. But when I push the button, it should give me 1 or 0, I guess. Here, let me, why is this not working? Why isn't the simulation working? I don't know, I'll refresh the page. Okay, there's button, code, serial monitor, start simulation, button. Huh. That's weird. Anyone know? What if we try this?
Yeah, it should give you something one way or the other.
Yeah, it should print something. I don't know. Let's go back to text. Oh, was that, maybe it was wrong code. I don't know. Start simulation.
And now that code's just for the LED.
Oh,
so the LED is blinking, so that makes sense.
Let's, here, I'll just delete this and then get a new one. Component Arduino. We want button and we want the code, text, start simulation, serial monitor. Oh, wait a minute. I don't think it actually prints anything. Oh, that makes sense. Yeah, the code in here doesn't actually print any data. I think, yeah, this code just turns on this LED. So I think it was working. We just didn't
that's right.
know what we were looking out for. So yeah, when you push this button, this LED turns on. So yeah, it has digital write to pin 13, and I think pin 13 also controls this LED. So yeah,
that is correct.
The simulation is working properly. Okay, let's go back to the presentation. Okay. Now we're going to go over a potentiometer. So first we initialize the potentiometer like a variable to 0. And then we have to set the pin, which we're just going to use A0 as the pin. as an input, and then we initialize the serial monitor. And then we use the analog read function to read the data from A0, and we store it into the variable sensor value, and then we print sensor value. And then we also have a delay just because we don't need it to run so many times. And then we can try that in Tinkercad circuits too. Okay, stop simulation. Okay. Where is it? Where'd all the stuff go?
The code.
Oh.
I think, yeah, there you go.
Was covering it, okay.
Yep.
Where's potentiometer one?
I think it's maybe the read
Oh,
analog
I think
voltage.
it's analog input or analog read. No, wait, is this it?
Yeah.
Yeah, that's, yeah. Wait, it's also analog input.
I think the
yeah,
input might not do serial.
Oh, no. Oh, maybe, wait, let's look at the code. Oh yeah, you're right. Okay. Analog read serial. Oh, analog in serial out. Oh, there's so many. Which was the one I copied the code from for the presentation.
Check the code for this one, and if not, it'll be analog in, serial out, I suspect.
I think it's this
that looks
one.
good. That looks good.
Okay. So if we start simulation and we open the serial monitor, so right now the potentiometer is at its minimum state at 0. And if we move it around, you can see that the numbers are changing. And that's how a potentiometer works with an Arduino. Okay.
Just as a note, I can see that the addresses do start at A0 and go up to A5, and the digital pins also start at 0 and go to 13.
Yeah, I just got a little confused because I don't think you can ever use 0 as a pin.
Because they're reserved for serial?
Yeah, I think, yeah. Okay. Now, wait, we already did this slide. Ultrasonic sensors. So first we set up the serial monitor as we've been doing. And then, so the ultrasonic sensor is a little bit different in the fact that it calls a function. We'll go over that in the next slide. But basically, we are calling the read ultrasonic distance, which just gets the distance from the ultrasonic, and we are multiplying it by this number, which gives us the value we want in centimeters. And then we are converting that also into inches too. And then we're just printing all that. And for the read ultrasonic distance function, so it takes in 2 pins. I think that, yeah, this uses, I'm not sure what kind of ultrasonic sensor you'll be getting in your kit, but this one can use the same pin for, yeah, that's how the Tinkercad circuits do. Yeah, they can use the same pin for this, but I'm not sure if yours can. But if it can't, there's 2 pins. So the trigger pin and the echo pin. So the trigger pin sends out the ultrasonic wave, and the echo pin receives it. So in this code, it's set up so these are the same pin. So at first, it clears any triggers just so it doesn't mess up. And then after it clears any triggers, it sends out a trigger. And then and then just, this is specific for this code. I'm not sure if you're going to need it. But after it sends trigger pin is set as an output just so it can send out data. And then trigger pin is changed to echo pin as an input just because it's the same pin. And then echo pin, using this function, the pulse in function, echo pin can read how long it took for the waves to come back. And we can see that in the circuit, Tinkercad circuits. Let's see. Ultrasonic. Oh, let me delete this first.
And while you're doing that, question from Jeff. So is the conversion from the ultrasonic read value to centimeters set constant based on the speed of sound, or does each sensor have a slight variance in hardware? So we'll have to possibly confirm and adjust that number.
I think it's based off of hardware.
and I think it is just a it is a timing thing, so it is definitely related to speed of sound.
It definitely is, but yeah, I think the hardware is different for different components.
Yeah, so the constant, you would find the constant in the data sheet for your sensor that would say that this means this.
Wait, let's go to code. Oh, I've just stopped. Okay, and text. And start simulation. Then we can open up the serial monitor. I really like how they, oh wait, where is this? Okay, there it is. Can I zoom out?
Oh. You can somehow.
I like how the simulation does it.
The scroll wheel does make you zoom out on my computer.
Oh, I don't have a mouse.
That makes it harder.
So this is pretending like this is a point in front of the ultrasonic sensor, kind of like how the simulation does it. But as you can see, it's printing the data in the serial monitor. If I go far away, the distance is much farther away. If I go closer, it's much closer. And if I go too close, it doesn't really work like properly. If I go too far, it also doesn't work too properly. Yes. And I think that is it. Yeah. Are there any other questions?
The kits have a 4-pin. Yeah, so the comment or question is the kits have a 4-pin ultrasonic sensor instead of a 3-pin. So how would that make things different? And
yeah, let's go to the slide. Oh,
yeah, exactly. Yeah, that's good.
Oh, anything else?
Maybe as an exercise, we can talk about that and what changes that would make.
So basically, I think, well, you can probably, like, if you look up 4-pin ultrasonic sensor on Google, I bet there's somewhere where you could just copy and paste code. That's often the case for programming.
And it is, in fact, I think the Arduino library, built-in libraries support the ultrasonic sensor we have. It's called the HC-SR04. And I used that for a project a while ago, and you can just import the library, and then there's a function that says like get distance in centimeters.
Oh, that makes everything much easier.
Yeah, you don't have to worry about the timing or any of that stuff. So
basically, if you had 2 pins for this, I think you would still want to clear the trigger just because it's good to do that. But you could just set pin mode of the pins in setup because the pin modes wouldn't change. And I think everything else would stay the same, like as long as you just make sure that these inputs are not the same number.
Yeah, and I think, I don't know what pulse in does here. It says, oh, reads, okay, so pulse in is reading the travel time in microseconds.
Yeah.
So yeah, that would make sense because you would just wait for how long it takes to get the signal.
It'd probably be easier just to use our Arduino library, the get distance. You can
yeah.
skip all these steps.
I agree. Are there any other questions, or if anybody would like to try and put any of this together while we're here, and we can answer any questions? The potentiometer is actually a good one to play with because you can see exactly what's going on.
Those ones are fun.
And those numbers are they're just a digitized version of the analog voltage. So if the potentiometer goes from 0 volts to 5 volts, and you've got a 10-bit analog to digital converter, that's what's actually on the Arduino for the analog PIDs. It's an analog to digital converter, and it just converts that value. 10 bits is 0 to 1023. And so 0 is going to be 0 volts and 1023 will be 5 volts. And if you have smack dab in the middle at 511, 512, that means it's 2.5 volts. So that's really all it is just measuring as Ari said, is a voltage divider. So you divide how much voltage you're reading across, and it just converts that to like essentially a fraction from 0 to 1023.
Mm-hmm.
So it looks weird when you're not used to it, but it's really just a digital representation of a voltage. And if you ever see the value from 0 to 4095, that's because it's a 12-bit analog to digital converter. So you've got more room for having a finer voltage reading. So instead of every tick or every number being 1/4000th or 1/1000th and 23rd of 5 volts, you're going to get 4 ticks for that amount because you've got 2 extra bits. So.
Mm-hmm. Are there any other questions?
Push buttons can be useful for if you have like a bumper or something like that. You could have it hit a switch so that when you want to run into something, your robot will stop. I think ultrasonics are pretty obvious. It'll detect something in front of you, as long as it's a bit of the size. If it's a wire or fishing line, you probably won't find it. But if it's anything kind of a centimeter or bigger in diameter or surface, the ultrasonic sensor will find it. Play with it, see what's going on. The biggest downside of ultrasonic sensors, don't point it into a corner, because the sound bounces off one wall, then off the other wall, then comes to you, and you get funny readings.
Ultrasonics aren't like too accurate, like up to a distance.
Mm-hmm. Ursula.
Do we know the approximate range of the ultrasonic sensor we're getting?
Let me just have a quick look. Do you know, Ari, offhand?
I don't think it's too far. I would say under 10 feet.
Yeah,
Ultrasonic sensor range, Arduino.
I think it's like a meter, maybe 2. It's the HCSR 04. Let's just go to
2 centimeters to 400 centimeters.
There you go, 4 meters.
Mm-hmm.
Perfect. They work pretty well. Like we did some exercises on our team, like navigating mazes and stuff, and they work pretty well. They maybe don't like so much if another ultrasonic sensor is facing them too, because you might be able to hear the other one. But this is like a $3 ultrasonic sensor. The FRC kits actually come with, I think it's Maxbotics, one of the Maxbotics ultrasonic sensors, and they have a lot more circuitry or design in them that they're quite resistant to hearing each other. So those are ones you can use on your FRC robot. We usually get a free one every year in the kit. So, and does it behave equally over the horizontal and the vertical? I think it does. I think it's a cone, like it's a 3D cone that it coughs out of. I don't think it's directed horizontally or vertically. That said, the receiver, it looks like it has 2 eyes. It's actually not 2 transmitters. One's the transmitter, one's the receiver. So if you look at that picture on our screen, in fact, the T is likely the one on the left that's got a T, likely the transmitter, and the one on the right that's got an R, that's likely the receiver, if I were a betting man.
Yeah, that sounds about right.
And actually, if you look at the traces there from the trigger and
you can actually see.
I think they curve in that same direction. Yeah.
There you go. I mean, they are dead stupid simple. If you really look at what it is, you apply a voltage to the trigger, it makes that thing sing at a certain frequency, and then you turn off that signal so it stops emitting a sound, and then you listen using the receiver, which is it's the same as a transmitter, but backwards. I think they're both maybe crystals, I'm not sure. And then when the sound comes back, it stimulates the receiver, which creates an electronic pulse, and your Arduino sees that. So it seems impossible that the device can talk, like emit a signal, stop talking, and time how long it takes to hear the echo, but that's exactly what it's doing. So it's like a bat throws out a signal and waits and hears the echo. Bats may be able to listen and scream at the same time, I'm not sure, but this one has to be done separately. So send a pulse, wait a little while until you receive the pulse, and that time times the speed of sound, put some math in there, and that's how far it is. How long it took to go out and come back divided by 2, because the trip is twice as long. That's the basic principle of ultrasonics. We covered pots. Buttons, Ari already said, it's really just you close a circuit. When you push on the button, you're either breaking the circuit or you're connecting the circuit, depending on how the switch is built. You can actually build it both ways. We call it normally open or normally closed switches. So don't panic if your switch goes to 0 when you press on it. That just means it's normally closed, and when you push on it, it opens the circuit. I don't know what kind of switches we have, but we definitely have some switches that are coming in your kits. And the other thing that covers the theory pretty decently. Any other questions or comments? You did see, Ari, how you can just go to Tinkercad and drag those parts with, like, the Arduino with the part on it. Like, that's really a really easy way to go and put it down, and then look at what the quote real code is, and then you can go from there and modify the code.
Yeah, you can test to see if like it actually is working properly.
Yep. Make sure you don't get any blow up pictures on it, so you short circuit something.
You can see if it's like a hardware problem, a software problem, or you just have something broken.
Yeah, definitely use Tinkercad to toy around, because you won't, if you fry something, it doesn't matter. It's only virtual.
I think Arduino is like, it's hard to fry them. Actually, never mind. I've fried a lot. But I think there is still some protection in them.
They're pretty good for what they are, but
yeah,
if you're not careful, you can blow it up. Yeah. All right. Well, I think we're good. If there are no other questions, we'll stop recording and streaming here. And if there's anybody who wants to hang out and ask anything further afterwards, you're welcome to it.